Thank you. So I know we're right before lunch and you guys are probably hungry. So I'm going to try to get through this talk in a way that you can both feed on the knowledge and then feed on food quickly. My name is John Connolly, and today's agenda is going to be a little bit about me, a little bit about change and software quality financial implications, common tactical software feature development, paradigm shifting that development focus, tactical DDD principles inside the core of software, and then rapid logical design, a rapid logical design option. And then we'll wrap it up and go to lunch. Okay, so about me, this is me. And my first computer was a Commodore 64. I don't know what your first computer was, but this thing was ancient and didn't do much, but it did a lot for us as kids. And I programmed all my games. And when I turned the computer off, I didn't have a disk drive, so I had to basically reprogram the game again. It took me longer to program the game than I did actually play the game. And that was one that came in on disk when I finally got a disk drive. That was my favorite game. And I was really puzzled when pixelated graphics came back into vogue a few years ago, because we had that like decades ago, and then it came back. I didn't understand it. And then when I got into database design, I was really interested in ERDs, and Access 2 was a big thing back in the mid-90s. And we built a lot of desktop software that way. Then I graduated to SQL Server 6.5, coupled with Microsoft ASP back in 97, 98, 2001. Everybody probably back then remembers the horrific nightmare of that system and how insecure it was. And then I moved on into .NET. And over many twists and turns, I became an analyst, a DevOps manager, or a dev manager, and in DevOps. And I really lived in this world between the developers and the business. And anybody who lives in this world between the developers and the business knows this special pain of the communication between these two groups. So when I became a consultant, I decided that I wanted to do this thing where they got a little bit closer. We kind of got out of our rooms and our buildings, and we came a little bit closer and a little bit closer. And then we pulled in the quality people, and then we pulled in the business intelligence people. But the business intelligence people didn't still get the data they wanted, so they weren't happy. And this is kind of what I do now. And what I like to do is work my way completely out of the picture so that the business intelligence person's happy and everybody's getting along and we have a great system, and that's nirvana, and we're not there yet. The future is now, the title of this conference. I hope to see the future happen now. And I'd like to show you a little bit of what people are doing now that is probably the future of many of your companies. There are things that are happening now in bleeding edge design, software design, that is going to become ubiquitous. It's going to become the thing you do. If you're not doing it now, you will be doing it in 5 or 10 years. They're already doing it in many companies in Europe. Domain-driven design is a very big skill set, and it is saving a lot of people a lot of headaches. And I'm going to show you how. All right. So when I look at the big ball of mud software, I kind of feel like I'm looking at the dark, ominous clouds of code. And change happens. And we talk about it. Change is the true const. Okay, so that's my only pun for the whole talk. All right, but change is the only thing that we can count on. So the cost of not handling change well, the cost of poor quality software in the US alone in 2020, according to CISQ, was $2.08 trillion. Half of that was security, but the other half was something else. And in 2021, that rose to 2.4. And it was a very well-researched body of knowledge that came up with these numbers. And that increase then led me to think, well, what happened in these years? These orange numbers are my numbers. This is my guess. We probably are getting worse. If we were getting worse between 20 and 2021, we probably aren't getting much better now if we're not tackling this problem. And if the CISQ was off, let's say they were over-exaggerating by half, is $1 trillion acceptable in waste? I don't think so. All right, so a little over half of that, that cost is in tech debt. What they said here was, in their study, cybercrime and losses was a focus. Supply chain problems with third-party software was a focus. But the biggest obstacle to making any changes to existing code bases, that was one of their main focuses, that we can't change software. Change is the only thing we can count on, and that's the one big thing we can't do very well. That's a problem and an opportunity. All right, so when someone comes to you with a change to the code base or to your developers, how do they normally react when they're dealing in the legacy system? Like, I'm gonna have to change what? I thought you told me you wanted it to work this way, right? So then that leads to, where do I even begin? Where do I even go into my code base? I don't even know where to go, especially if you're new to a company and you haven't been there for more than 6 months or a year in a typical software company, software environment. I don't even know where. I'm gonna have to go talk to 6 different people to figure out how I can make this change. And then when you finally go look at the change, it's like, who wrote this? And then you realized, I did that? That was 3 years ago and I wrote that? That's horrible. So time equals money, and that waste that we talked about, that those trillions of dollars in waste, happen in little slices all day long, every day. That's what's happening. It's not one big waste, it's a billion little wastes that are happening. So time spent agonizing over a change costs us. It doesn't just cost us money, it costs us mental health. The time spent trying to understand current code costs us. Trying to understand how to change, undoing bad changes costs us. Providing ineffective solutions costs us. And there is no way to fully eliminate this. Let's just be honest. Especially in an R&D environment, heavy R&D environment, you're going to make a lot of mistakes. And that's what we expect in an R&D environment. But once you get past R&D and you finally have a designated solution, are you still toying with the design, or do you have a quality design? All right, is there a way to there is a way to reduce these costs significantly by design. Adaptive change can be very profitable. So it's not just about the altruistic of making clean code. This is about, hey, what if our processes were actually efficient and the business could save maybe $3, $4, $5, $8 million a year in the total cost of ownership of software. All right, so let's reflect a little bit. How do we build software today? Just in your mind, imagine that. How do we build software today? Why is changing software challenging? What are we missing? And of that, what are we missing? What's the key ingredient? That's what I'm going to try to address a little bit today. All right, before I go there, we may be thinking, and I hear a lot of this, so I'm going to just address it now. We may be thinking, hey, we were in waterfall and there were too many delays, so we moved to agile and we didn't really have logical designs. We had the UI and we had the database, but we didn't really do that step. And then we just went straight into people's tickets and burn downs and burn ups, and we're focused on project management, not product management. That's been a common shift this last 3 or 4 years, people moving to product. So in the UI and the UX world, we have wireframes. We do have design. And in databases, we do have entity relationship diagrams. But that's a poor logical focus. And then we spend a lot of money on tech, which are servers, and they all do them a little bit different. That's not about this topic. And then we have artificial intelligence, which now we have the hype and potential entropy consequences and like everything that AI is. And that doesn't seem to be the silver bullet to save us money. In fact, AI is costing us more money than it's saving us right now in the industry. And the reason for the hype, in my humble opinion, is that it's costing too much money to do. So we need to actually sell this thing and get people buying into it so that we can maintain all of the servers required to make AI work. All right, so the power of change. Adaptive software welcoming needed change prevents waste. If we can change it quickly, then we're not wasting our time. Maladaptive software blocking needed change creates waste. Both of these are powerful. One is powerful towards efficiency, and one is powerful towards a destructive or an inefficient nature of software development. Both are powerful. Which way are we going to invest into into what power. So how adaptive are the systems you work with today? And when I ask that question, I don't ask it in feelings, even though we feel it. But truly, are we measuring it in hours, days, weeks, months? Are we actually adapting quickly, moderately, slowly? Where are we at? Some people say years. I can't change. I met a guy in the government down in California working in Medicare, and there were changes that couldn't be implemented for 3 years. Not because they didn't need it, but because of how badly the software was designed. All right, so what do we have to do? What is our key focus? What I propose, and what other people are proposing in the industry, is we move to this thing called systems thinking. This is becoming more prevalent in the industry. And Diana Monteleon is one of the key proponents of systems thinking. Her class, I went through her class, and it really did kind of open up this idea of nonlinear thinking. Systems work a little bit different than what we probably have been taught in the past. And Eric Evans, the creator of domain-driven design, has a way to navigate building systems according to the domain you serve. So if we're going to do systems thinking, we probably need to have that thought process and pattern that allows us to implement that systems thinking, and domain-driven design is a good way to do that. So what's a domain? Everybody asked me this question. I got asked this question last night at dinner. What's a domain? A domain is just basically an area that you're trying to solve a problem for. And these are a bunch of examples, and you all probably work in one of these or something like this. This is not exhaustive. There are probably hundreds that I could have put up here. And notice racing is a little bit pushed to the side because that's sort of a subdomain to sports. But for some people, it's not. It's like racing is racing. It's not. It's a sport, yeah, but it's more of its own domain. And so that leads us to subdomains. What's a subdomain? A subdomain is generally the areas within a domain area that enable the domain to actually function. These are the functional areas of the domain. Okay. Any questions so far? None. Okay. All right. Types of subdomains. This gets to be a DDD high-level concept. We have core subdomains, supporting subdomains, and generic subdomains. And the only difference between these is basically the core is what you do in your business that differentiates you from the rest of your competition. The supporting helps you do that, and the generic is just all the stuff that's around it. If you're not an accounting firm, then accounting is probably not your core domain. Accounting is something that's generic that you're doing on the side. If you're selling buckets of paint, then accounting is just a generic domain. But now e-commerce is probably your domain. And then the subdomains that fulfill that are probably you're supporting. All right, so how do we build these adaptive quality solutions to save money and stop wasting money? We need to have a better understanding of what software is. I didn't realize this till a few years ago. I started asking the question when I started my company. I started asking all my clients, the CTOs, the CIOs, the senior solution architect, whoever was really sponsoring me into the company to get things designed well. I would ask them this question: how much percentage-wise of your code base, of your complex code base, the stuff of your core, how much of that percentage-wise is logical function, methods, like doing things to data, not the data, but doing things to data, and not the UI, just we have business rules and all of that. And they would invariably tell me that basically 10% is UI, 10% is database, and up to 80%, but often 60 to 70% of our code is the logic. What I find interesting is the industry has spent the last 40 years designing the UI in the database. And they love it. And it helps the developer, create these products, the UI products and the database products, because we've designed it. Now they don't have to ask any questions. Why are we asking so many questions over here, maybe? Probably because we're not designing the logic in a lot of companies. And I'll show a little bit more about that. But we could learn from wireframing. It is best with user input. sometimes that logical work is best with, most of the time, it's best to understand the domain and the domain expert who understands what that logic is supposed to do. All right. And even in a brownfield project, we'll print out the UIs and then we'll make adjustments, and then the UX developer knows what to do. So we could actually take the logic that's currently existing and then map it out and say, okay, what changes do we need to make to this model? All right, so it still costs less to verify. The reason we do design is because it costs less money. It actually costs us less to do design work. Everybody thinks, oh, I don't want to add design. Well, you're not adding design, you're subtracting development. You are adding, but more subtraction is happening when you have a complex system, if you're spending time doing a model that everybody can understand. All right, so businesses apparently do waste trillions in software. So this is a true opportunity for your business to actually invest in a design methodology within your company. All right, so we want to hit the target. Can we use the strategy of wireframing for business logic? What if we could be inspired by that part of the industry to do logical wireframes? What if we could make sense of a system faster by the entire team? What if we could make new enhancements fit the current design almost as if they were anticipated? What if we could make software easier to read by design? It's just easy to read. I know exactly where everything is. What if we could reduce the impact of change to just the components we directly change? What if we knew that when we went to make a change, it wasn't going to kill the whole system? We just knew it. All right. What if we could rely on the business to tell us exactly what they want in a way that we could clearly understand, design, develop, and test? So to get there, I don't know if you've ever driven a motorcycle, but when you drive a motorcycle and you want to make a turn, you kind of need to know you're looking at the end of the turn. You're not looking at the road along the way. So what we're going to do today is we're going to look at the end of the turn. And to get there, you're going to have to devise a way using the end result. I think you'll find resources, and I'll bring some up too, that'll help you make this turn. All right. What we did in the day when I was a database designer is I would create my orders entity, my customers entity, and my products entity. And I would attach all of the contexts, all the logic from all the different areas to it. This is what you call the canonical data model, by the way. Okay, this is how the big ball of mud gets started. This is the inception of a big ball of mud. If your software started this way and never left, and it feels like a big ball of mud, you now know this is how you started making that big ball of mud. What happens is we decide on the UI wireframes with all the different contexts. We decide on the database with all the different contexts. And then we try to shove logic into the middle of it and hope it works. That's kind of how software development has been for me when I was going through the ranks. When I paid my dues, I was given this and I was given this and I was said, go make it work as a back-end developer. And I wasn't even on the UI team or the database team. I was in the back-end development team. All right. So what we want to do is stop that. We want to stop that. But just stopping that doesn't help. Like saying, OK, don't do that anymore, right? That's like, stop that. OK, well, that's great. What do we do? What we want to do is turn our focus to three things: the context, the capabilities, and the contracts. Some of you have heard this idea before, but I want to elaborate on it a little bit more on how crucial this is as a foundational design concept. The context identification provides a domain-honoring differentiation of contexts. In this context, we have this. In this context, we have this. And we can map those contexts out. A structure for a unique language per context. So every context can own its own language. And have you ever had one word mean two different things in the business? Or two words mean one thing? Like 6 different people, you have their own word for the same definition in the same context. In domain-driven design, we don't allow that. You get one word, one definition per context. You can have the same word in different contexts and have different definitions. But in this context, you can't have a different definition. We're going to use one word and one definition. Why? Because that word that you're using in the business is going to become the word you use in the business, also the words we use in the code, the method, the properties, everything is matched. Remove the translation layer, removing the waste. Remove the translation layer, removes waste. Okay. A boundary for which a value stream team can know what is and is not their responsibility. They get autonomy from having this contextual focus. If I'm on a team on the billing context, and that's all I do, when a billing change comes, I know exactly where to make that change. All resources to provide a capability. So in context, and we're getting to capability next, but in context, I'm not having a UI team over there and a database team over there and a backend team over there. Everybody comes together. They're on the capability team. They're on the value stream team. If I need this value, I need everybody that can provide me the value on that team. That includes the domain expert, the quality tester, the product owner, everybody, the business analyst. It doesn't matter. Whoever's going to help provide that capability, they're on that team. Content, it gives us content useful to develop a map, which I was talking about, of the current and future solution. And it gives us scope narrowing to allow for a greater focus. All right. Capability identification provides domain functionality that should or should not be in the software solution. It gives us a deeper understanding of the context. So as we understand the capabilities, we understand the context. There's a relationship between the capability and the context that starts to create clarity in the business. It's an opportunity to iron out differences of understanding in the domain language, way the system's supposed to work. I can't tell you how many times I had two people in a room telling me, no, it works this way. And these are two business people. This isn't even IT. IT's in the corner like, we don't know how it works. And you guys say you know how it works, but you're not saying the same thing. So we make sure we iron out those capabilities in these design sessions. Basis for domain modeling. It gives us an ability to actually model the domain in a solution and a way to coherently talk to domain experts about what their systems need to do. The contract identification provides explicit interconnections between contexts, a reduction of confusion about what is and is not shared between contexts. Like the contract is this narrow. We are sharing these 4 pieces of information with the rest of the other subdomains, the other contexts, and everything else in our context, we own. We can change any of it the way that the business needs to. All right. A clear understanding of the various types of relationships between contexts. DDD has a list of about 7 or 8 different relational styles, and they're not database relationships. They're working relationships. Is this a customer-supplier relationship? Is it a partnership? Is this a separate ways? Is this a conformist relationship? Whatever they do, I just have to eat it. Speaking of eat it, we will get to lunch. All right. Distributed systems. Many of you have seen different models of distributed systems, hexagonal architectures, and so forth. In a domain-driven design world today, not when the Blue Book was written by Eric Evans, that was application style. This is now system style, distributed style. So DDD has matured over the last 20 years. And what we're doing is we're saying in these contexts, we're going to have capabilities that then have contracts to a platform that runs messaging through and then sends wherever you need through Azure Service Bus or N-Service, and with N-Service Bus monitoring. And the idea is that now I have no weird separation of concerns. When I say weird separation of, we talk about separation of concerns in software a lot. A weird separation of concerns is generally, from a business perspective and from a domain-driven design perspective, is based on technology. We're a technology group, and I'm telling you, that's a weird separation of concerns. From a design perspective, when you're thinking logically, the physical implementation, you may have separations of concerns, but when you're thinking about a logical design for the business, these separations of concerns are what model the domain. Is really critical to get this. All right. So inside one of those, you'll have branding contracts for the UI and systems contracts for everything outside of that hexagon. I didn't put a hexagon here. This should have been a hexagon. But you'll have the UI, the controllers, the business logic, the database, the data product for analytics. Everything is inside that context. All right. So this is a good example. Billing has process payments and balance reconciliation as capabilities inside of that context. And these have their capabilities inside the context. What you don't see here is customer, product, and orders. You see activity. You don't see nouns. When we're designing in DDD, we're actually trying to figure out the behavior of the system. Side effect-free design requires you to focus on the logic, not the small bits that are outside of that. And then what we do is, when we were doing the old style, we had UI teams, app teams, dev teams, and then the business intelligence. They were off in the corner. They didn't get any, and they didn't get the notification that the database was changing and that they need to change the reports too. That's what my DB friends, my BI friends have told me. They feel like they just don't get any information because everybody assumes they have the information because they have access to the database. So instead, we're going to create value stream teams and platform teams. We're also going to create enabling teams that have special skill sets that can roam around and help these people do their job better. And we'll create core component teams. They're like very complicated component teams that maybe one or two of these use, and it's residing in the platform. Or maybe there's a component inside of one team that is just needs its own team because it's this massive calculator that only Bob and Ralph know, and we need that expertise, but we don't need the rest of the team to focus on it. They just need a little API out of it. So be very strategic about it, but be very contextually focused. All right. The person who's helped me the most understand distributed systems is Udi Dahan. So I'll give you that name just as a way to point you to more about how to create a better understanding at a low level, how to separate concerns contextually from a transactional perspective. And I know some of you may be thinking, but wait, we do need to actually have one view of the customer. And I'm getting to that. All right, so applications start with an understanding of the UI and the data, and then try to connect the business logic. Systems start with an understanding of the network of capabilities, starting with the logic, while holistically making appropriate UI data and analytical design choices. The context is, what are we actually doing here? All right, model it out fast. You could use event storming, service blueprints. These are like tactical ways to actually model out your domain. But whatever you do, do it with domain experts. The business. Domain experts are usually not product owners unless they actually processed loans for 20 years and now they're a loan domain expert. And now they went to the product ownership world. But usually product owners are hired from the outside and they don't know the domain that they're working in. So they can't be a domain expert if they've never worked in the domain. Period. This guy, Alberto Brandolini, is the guy who invented event storming. It's the tool I use most prominently to map out the user persona, the command, the system, the event, and it just strings along. I'll show you a picture of one of these that I did with out in Porto, Portugal. But the idea is that you have when you break one logical step down, it has these components. And when you know what these components are, by definition, explicitly, the business can tell you exactly how it works. So we did this as a workshop over in Porto, Portugal, me and another guy named Nick Toon. And we did this strategic workshop. And what we did to get the context is we found the pivotal events that went from one context to the next. When you find a pivotal event, then all of a sudden now you've got a boundary. And so when you bind the context, this is what we call in domain-driven design a bounded context. When you bind the context, now you know where you can put your capabilities. You can put them in this solution and make that module. So that's Nick Toon, the guy I did that with. He wrote this book, just came out, I think this year. Architecture Modernization has a lot of these types of strategies in it. By the way, I'll put these slides out on them. I'll have them out there. Nick also came up with this bounded context map or a canvas that allows you to kind of get it all in one page. Work with the business. This is in the GitHub under DDD-crew. That's the group, and it's the bounded context canvas. And when you get done with event storming, you can go through this exercise with the business and say, okay, did we plug all the holes? Did we miss anything? In tactical DDD, which was the point of this talk, I had to set all that up for you to be able to even understand what I was going to talk about here. So I apologize for the length of the talk so far. But What we're trying to do is, in context, process a bill payment. This is just an example. And if we never had this payment before, and we're not retrying it, we're probably going to generate it in a factory, or we're going to new it up somehow. But in DDD, we generally use a factory. And if we have that payment and it's not fully done, or there were some issues, and it's in the database, and we would pull it out of a repository pattern. And once we get the instance of this bill pay capability, we have all the behavior and the data to do the transaction, all inside, encapsulated in this one block. Whatever it takes to do that capability, it's inside there. If it's not about this capability, it's not in there. And the only way to get into this is through the aggregate root. So you might have a lot of objects and a lot of stuff going on in here, but the only way to use any of it is to put a process bill payment command into it. And it does that work. There may be other features that this bill pay capability can do. So you can put 2 or 3 different commands in here because it's appropriate contextually for that to happen. But be careful, because you can put 50 of these inputs and this aggregate can become its own big ball of mud. So as a designer, we go, okay, we only want 1, 2, 3, 4 commands at the most, and we want them to be contextually bounded together, and we want that capability to be cohesive, not coupled, right? We want to decouple things that don't need to be there. All right, and then out of that, we have a bill paid, or we have a bill attempted not paid, or we have a bill partially paid, and whatever the other systems do with that, that's not the part of this code. There's a different context that handles, or possibly a different capability within this same context. So you can have multiple capabilities within one context. The other option is to have something that has no data stored, and that's just a domain service. And all you're doing is saying, I need to do some funky calculator, debt to income ratio, something that I don't really need to store data. I don't need to get data. I just need to put 2 pieces of information or 7 pieces of information into the calculator, and it needs to spit out a result or no result. So those are the 2 main tactical DDD overarching patterns. Imagine if all of your software was written in these 2 patterns. How boring. How boring it would be to know where to go to write all your code. How much waste do you think there would be? All right, so contextually, there's a lot of things: language, boundaries, needs, resources. There's just a lot of things to consider about the context. And this is why this work is a little bit hard. But if you kind of get used to this and you get your mind into this, it starts to decrease the amount of cruft and about a churn that's happening on the back end in development. We don't have to guess at this stuff. We can look at it up front. That's strategic DDD. And then capabilities are tactical DDD, which is basically what I just showed you with the inputs and the outputs. And what we're doing is we're building the core. We're not building this. We're building a little bit of the supporting domain, and we're doing a little bit of the generic, but mostly we're buying generic. This is really about your differentiator. Your competitors are probably not doing this. So if you get on this and get really good at this, you might beat them. All right, contracts, the modular systems, the Udi Dahan stuff. Okay, so this is where this gets to be very important and how this works. It's a very important science about how networks are not reliable, and to create the outbox pattern or those types of patterns that prevent failure from messaging is really important. But all of that doesn't mean anything if you're doing the wrong thing from a business perspective. Okay, now we can be inspired by successful outcomes. We can make sense of a system. We can make new enhancements. We can make software easier to read. We can reduce impact of change. We can rely on the business to tell us exactly what they want using event storming and other modeling techniques. All right, so design quality. Strategic domain-driven design helps us set the service boundaries of the context. I'm just repeating myself in a different way for those of you who learn a different way. And tactical domain-driven design helps organize code inside of those boundaries, and distributed architecture or event-driven architecture helps decouple unrelated data and transactions capabilities, and contracts from each other. All right, modeling tools help us rapidly map these out faster than hackathons. Much faster than hackathons. Okay, every choice then should be, how does this improve or degrade our relevant designs for the future? Is the future now? I think the future is now. We actually need to be thinking about the future now. To recap, change is the true constant. How do we design for change? How we design for change either prevents or creates waste. We are wasting around $3 trillion annually, and most developers are still trying to develop systems using application development paradigms rather than system. The key is the logical context. Context is king. Systems thinking starts with understanding the contextual behaviors and interactions of an ecosystem. This is not the best way to use C#, the best way to use JavaScript, the best way to use some new tool coming out. This is about looking at the domain. Domain-driven design is all about understanding what are our contexts first. What are we trying to solve before we solve it? Designing behavior intentionally through logical wireframing using event storming, and then forming your teams around capabilities, not around technologies. All right, the bottom line, improving adaptability can improve profitability. So when you go back home, hey, we heard this talk, it was all about DDD, and it turns out it's not just about some weird concept, it actually can save us money. And we might be contributing to $3 trillion in the US every year, by the way. Logical wireframing can provide that benefit far better than no intentional design. I highly recommend this book if you want to learn DDD kind of as a starting place. Vlad Connolly is a frequent speaker at DDD Europe. He just came out with another book, Balancing Coupling and Software Design and Architecture, which is amazing. A whole new take on coupling and decoupling that is very, very good. And that's my talk. Any questions? Will do. Yes. Did you have a talk? Oh, I'm sorry. Did you have a question? Okay. Yes.
So at that point, so you talked about people getting in a room, all the same room. Maybe it's some point to arrive with that vocabulary. And so I was looking at one of your slides, I think it was the billing capability. And within that, there were entities, relationships, events. To me, that kind of feels like maybe that's what some vocabulary is invented, maybe not. So my question to you is, what in that example, what would the vocabulary be there with the billing capability? I don't know whether or we hide some of that from some of the entities.
Okay, so the vocabulary we're talking about is the contextual vocabulary of the domain. So it's not about object-oriented vocabulary or anything technical, first of all. So the question is, what vocabulary are we looking at inside of these various contexts and their capabilities? The vocabulary is all about how that context manages like if you just had a legal yellow pad and you were putting information on it and then putting it in one of those routing envelopes back from the 80s and passing it to the next person, and then they did something with it, and then another person added a form to that. How does the business actually function? What do they need actually done? What are these activities? And how do you name them? And why do you name them that way? And can we call them all the same thing within these various contexts? So designing a glossary or a vocabulary for each context becomes owned by the teams. And when I say teams, I'm not saying tech teams. I'm saying capability teams that have a layer. It's you've got the domain expert, the product owner. You've got everybody in that team providing the capabilities for these contexts. So they're creating their own language, and they're all unified on that language in the context. And the only thing they have to actually communicate to the others are what's inside the contracts. And that language has to be agreed upon between teams. But inside of a team, it's really about the domain language, because we want the business to speak the same language and we want the code to read as that same language. A business person should be able, not knowing anything about object-oriented programming or procedural programming or functional programming, they should be able to look at a code file and see a method signature and go, oh, that's where you're doing my bill payment. Oh, that's where you're verifying identity. Oh, that's where you're doing this. Oh, that's where you're doing that. They should be able to know exactly what you're doing in those. Not so much the if-then loops and the for loops and all like what's going on with the logical code, but the signatures of all of these things and the properties that you're creating. In fact, I highly recommend you not use a string. I highly recommend you use a first name object and a last name object. And you create these properties that are domain designed and hide the generics. Hide them because they don't mean anything. I want my developer, if I'm a CIO, I want my developer to pick up a file and see the domain language because the business is going to be asking for things. And I want them to be able to find it. It is self-documenting code at the next level. Does that answer it? Okay. Any other questions? Yeah. So I generally like to keep all of my, I generally like to only have 2 or 3 commands per aggregate. But honestly, you can break that rule when the context makes sense. It's really less about formula and all about critical thinking of context. And oftentimes we miss the context separators, the separation of context concerns. So if it starts to grow big, we probably need to step back step back a bit and go, why are we putting all of this stuff together? Why is this not simple? Because the developer's cognitive load can only handle a certain amount of code and concept within that code. And the more you put in there, part of the reason to break these things apart is just because the developer needs to be able to focus on what they're doing. And that needs to be in line with what the domain is thinking. So that's the hardest part. This is the real challenge of design. But I would say you want to keep it as small as you can until you can't, and then have a plan to figure out how to improve that design. Design is always happening. Change is the true constant. So monoliths can, the question is, are we talking more of this for a distributed architecture versus, or a microservices architecture versus a monolith? There's kind of a new thing coming out of a modulith. So people are starting to work out their monoliths into modules inside the monolith. That is one way to start creating distribution of context. And I think it's a valuable one. It's Kent Beck's way of saying it is make change simple and then make the simple change, or make change easy, then make the easy change. And so what we do in domain-driven design is a lot what Martin Fowler talks about with the strangler pattern. We will take something in the monolith and move it out, make that functionality work, and then basically put endpoints on the old functionality to have events that were coming to it be routed to the new functionality, and then events from the new functionality routed as the output. And so now we can turn off that little light bulb can be turned off now inside the monolith, because now we have a new light bulb. And we can put 1,000 points of light, I think I heard that somewhere before, around the monolith and turn off little bits as we go using that event-driven architecture. And in domain-driven design, we use an anti-corruption layer to translate between the monolith and the new system. So there's a strategy for that. So it's for both. It's all the above. You can do DDD on a legacy system that's 20 years old. Hey, Cal. Yes, so that is all starting to become developed. There are companies out of Germany and others that are developing modeling tools that are not quite the same as the old modeling tools of UML days. They're a little bit more focused on what we're talking about here. They're specifically DDD style modeling tools. Until then, the post note is perfect, quite frankly, to get the conversation done and then to communicate what comes out of that conversation, the relevant core need. You can use the bounded context canvas. And there are other things like that that are pointed to by these other authors that I showed you that they deliver as deliverables out of design into a domain model, which is something we didn't talk too much about here, but a domain model is what the developers need to basically implement the domain design. And a domain model is just basically a class diagram, you know, with an aggregate boundary around it with an aggregate root. That's beyond, that's all stuff you learn in DDD school. Right. Does it add additional overhead for quality? Maybe, and I'm not sure it matters because the quality is going to go up and all you're doing is verifying that it's going up. So I would say initially there's probably a bump in focus on doing something new and different. But as you get used to it and you realize things are working, you can ramp down as concerns go away. Yes, so you're talking kind of like so this is Conway's law. So the question is how big do contexts get and how big do teams get and that kind of thing. So we're trying to manage size. This is all about Conway's law. Your organization is basically the reason most companies have a monolith is because they hired 400 developers to build a piece of software. That's why you have a monolith. So if you separate those teams out into 5 and 6 people group teams and give them different contexts and then give them the ability to contract with each other, now you have a network of capabilities. You have the same number of employees, you're just managing them differently. Now you can't change from 400 on a monolith to 400 distributed into like 50 teams overnight. You have to basically do what I was talking about one by one, pulling out bits of features and have a roadmap for that. And then your team size really should be about 2 to 7 people. It shouldn't be like a context with 19 or 40 people on it. That context will probably need to be split out into 2 or 3 different contexts. That's it. So the question was the main effort to separate concerns? The main effort is to separate concerns. The main reason to separate concerns is to reduce waste, to be more effective and more efficient and more capable of handling change, more adaptable. Yeah. I hear other questions stewing around, but I don't want to force you to ask them, but I'm really wanting them. Yeah. Excellent question. I heard this question through several, as I was giving the talk, people were like, why does this matter to me in QA? Okay, we were talking about this over the last couple of days in this conference because I'm not obviously a different animal than I'm the different type. I'm the I don't know, I'm the mallard duck to the geese that are swimming around, right? So if I'm QA, I put my QA hat on. Okay, I've done software since '97. I tested my own software for a lot of years because we didn't have a QA department. We had a developer and somebody in the business telling the developer what we need. And so I had to decompose the business, write requirements, write software, write the tests, and deploy the code. Like I was everything. Okay, so I have had that experience of how would I test that? I don't know how I would test without a design, honestly. I actually feel bad for quality assurance people who get no information about how something is supposed to work, what the domain was intending to do in the first place, how these things were supposed to be interconnected, what are the results you were actually expecting from this software. Like I have no direction whatsoever, and you want me to tell you if the software works? What does works mean? Without a design, I don't know what works means. If I'm building a car on a manufacturing plant and I don't get a design and they say, go build a car, what am I going to build? And then when I build it, when the QA people at the very end test the car, well, it looks like a car. Like that's about the best you can do with software that has no design. Now, I'm not saying that you don't have the skill to be intuitive, to extrapolate, and to try to go, if I was an end user, would this seem functional to me? Yes, but are you interviewing the end user to find out if that's the functional? So if I'm a QA person and they're not giving me the design, then I'm going one step above that and talking to the people who are like, what the heck did you want this thing to do in the first place? Like, what am I testing for? Not just bugs, because bugs, like we were talking about in yesterday's session, bugs are opportunities to improve things, and that's great. But functionally, did this provide it? I had an instance once where a domain-driven design thing came up. They didn't do it. The terminology, they use the same words between IT and the business, not even close to the same definition. Software came out, it worked 97% of the time by chance. Like the fact that it worked that much was like, I was blown away. But the other 3% were actually very critical. And every time the business says, but this isn't working, and they're like, well, it doesn't work that way. Well, that's what they told you. IT says it doesn't work that way. The IT needs to learn to become a service-oriented organization. We serve at the behest of the domain, not the other way around. So if the domain says we need something and they don't make sense, our job is to go, let's make sense of that. And then let's provide you the solution rather than say, no, it doesn't work that way. Please, if you're that person, I'm sorry if I'm stepping on your toes. I would like for IT to stop getting a bad rap for saying no and say, let's talk about that design. Let's figure that out. And these tools give you a way to do that in a very rapid fashion without even having to code. Fast. If you need to contact me for any reason, there's my stuff.